and welcome to lesson 1 of week 4. In this lesson, we are going to look at conditional statements in Python. So conditional statements are statements that we write when we want to do something if a condition is true or as long as a condition remains true. We have different operators that we use. If you refer back to your previous lessons, looking at the operators we look at, we had logical operators. So as we go along, we will use these operators. Also, we have stated previously that Python relies on indentation for scope. And when we talk about scope, we mean a group of code that must be executed together as a single unit. When we want to write a conditional statement, or let's use the English language for instance, when we want to say something that depends on something, we use the word if. We'll say if something happens, then we want to do something. It's the same thing in Python. We use the if statement to specify what happens when a condition is met. Let's say I have a variable a is equal to 6 and b is equal to 7, and I want to say if a is equal to b, I want to do something. If it is greater than, I want to do something else. If it is less than, I want to do something else. Python has the if statement to execute a block of code if the condition is true or if it satisfies the condition. It has the elif statement that provides an alternate condition if the first one is not true, and then else is like a catch block that says if all the conditions preceding this is not true, do this. So we have the if, the elif, and the else statements. You can use multiple if statements. You can use multiple layers of elif statements with the if statement, and then you have the else statements that execute if no condition is met. So let's do an example. I want to say if a is greater than b. So this operator greater than we use to compare two things, comparison operator, and we use that in conditional statements to compare two conditions. Now the scope of Python uses indentation, which means the spaces before the block of code, which tells Python that everything I'm writing should be executed together. So if this happens, I want to print a is greater than b. If this is not the condition, I want to state another condition, elif, like this, and I'll say elif if a is less than b, I want to do something else, print a is less than b. Now if a is not greater than b, a is not less than b, what else do we have? We have if they are equal, right? You can have another layer of elif statement like this, or say elif a. To compare two things, we use double equal like this in Python. Okay, so say if a is equal to b, we want to do something else. But since this is the last condition, a will either be greater than, less than, or equal to. So we can use the else statement to specify the last condition, which said print a and b. Now when we use another layer of elif here to say if a is equal to b, in the if that maybe we're comparing two things that are not comparable, and we know that the condition might not always be true. For instance, let's say b is equal to, we don't want to say a and b is equal when we print this. Let's run this first. Let's revert back to what it was, run it, and then let's see what it prints out. So we have a is less than b because a is 6 and b is 7. When a becomes 8, a is greater than b. When a and b are 7, a is equal to b, or a and b are equal. So we see how we use conditional statements if we want to check things and do something if a condition is satisfied and something else if not. Now if we have something like food here, a and b will never be equal. They will not be greater than, they will not be less than. When I run, it will give me an error because we're trying to compare two things, an integer and a string. So when you use your comparison operator, you have to make sure that the values that you're comparing are of data types that can be compared together. So when we have this, we can have a check to say if a and b are integers, then we'll run the conditions. But before you start thinking of this depth of checks and balances is when you want to push your code to production. You are building a software. You want to anticipate every error that can be made. You want users to enter data in a form field, and once this record is received, if it's supposed to be an integer you're expecting and they send a string, you don't want your system to fail because the user put a string. And so you want to have those checks and balances, and you use the if statements to check all of the different things you want to check before the comparison starts. There are situations where you might want to use a shorthand. For instance, we have something we call ternary operator. So instead of saying if a is greater than b, print a is greater than b if a is less than b. This is a short code. It's okay. When we want to write this using the ternary operator, say what happens if the condition else something else. So in the case of what we just did, we'll say print, so we'll put what it prints here, a is greater than b, and we're printing this if a is greater than b, and then we'll say else, we'll put A is less. And so when I run this, I'm going to close this. So when I run this now, we have A is less than B because A is 7 and B is 8. But you see how we wrote this on one line? We call this the ternary operator. As you go along and as you write, you understand how to do it. You are writing the print statement, but within the print statement, you write the conditions that you want to meet before a particular statement is printed. So because we had if, elif, and else, then we use A is greater than B if A greater than B, else A is less than B if A less than B, else A and B are equal. So let's say we have a more complex scenario. Let's use age groups for instance. So let's say we want to have age groups from 1 to 30. So we have these groups and we want to do something different for each of these age groups. We can use if statements, but we'll have a long if statement. For instance, let's say we create groups now, and let's create the groups as a list. So let's say group 1 is equal to, we want 0, 1, 2, 3, 4 in group 1, right? And we want group 2. So we'll have 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and then we'll have 25 to 29 here. So this will stop at 29 or 30. So we have 6 groups and we put this in the list. Now I'm going to show you different ways that this can be done. We can use group, we can later use the range function, we can use an if statement, we can use the match statement. Now when you are given a task to do, you want to write your code in such a way that the code is efficient and fast, right? And this is something you will learn in another course, Foundations of Software Development, where we look at data structures and algorithm. But in this course, we want you to understand how to write the codes first and the different ways you can write the same thing. So we have this, and let's say somebody's age, we'll say represent by x is equal to 10. And we want to do something if the age is in a particular group. So I want to say if x in group 1, now I use the in operator. So when we look at the different operators, we have this operator here, in. So if x is in group 1, we want to do something. Print x is in age group 0 to 4. We can do the same thing here. We're not using elif. We can use elif to say if this condition fails, check this condition. If this one fails, check the next. But if we wanted to check every condition, we can keep using if statements. Now, if you keep using if statement like this, it means that it will check every condition. Even when it meets this condition, it will still check the next condition. So we can say if x in group 2, and then we'll say print x is in age group 5 to 9. Now, will this be an efficient way to write your code? No, it will not be, because we can write if statements up until group 6 down. What we are telling the system to do in this case is to check every condition. If you check this one, if you don't meet it, there's nothing you can do. Just go and check the next one. If you meet it, still check the next one, and you keep checking everything. But when we use elif, it only checks what is in the elif if the one preceding it is not met. Once a condition is met, then it stops the conditional statement. It stops completely. So if I say elif x in group 3, I'll just copy this so we can be fast. X is in age group 10 to 14. Elif x is in group 4, x is in age group 15. And if x is not any of this, we want to put an else statement that it will print something. So we have this conditional statement now, and we use if, elif, elif, elif down to else. This is not an efficient way of writing code. So x is 10 and x is in age group 10 to 14. When we change the value of x to be 23, for instance, it will tell us x is in age group 20 to 24. So you can see this works. But apart from the fact that it works, is it the best way to write this code? What if we say if x is in, there is a function called range. And when you specify the range function, it means that you want to have a sequence of number. Usually it increments by 1. So it starts from 0 until the number you specified, excluding that number. So if I say x is in range 5, it means that I'm printing 0 to 4. If you are not sure, you can specify the start to be 0 here. And if you want to put a sequence, like how many, instead of increment by 1, you want to increment by 2, you put 2 here. But now we want it to be from 0 to 5, excluding 5. So print everything from 0 to 5, but don't print 5. So say if x is in range 0 to 5, put this. But I put if x is in range, we want to start at 5 and we want to end at 10, but not 9. So that's from 5 to 9. We want to do this like this. Let's look at how we can use the match statement to change this. Say x is equal to 23. We can use the match statement to start with this match. We want to provide different cases that we want to match. So the case here is 0, 1, 2, 3, 4. You can say case 0, then you do something for case 0. Print x is in age group. Then if you say case 1, you'll be repeating the same statement. Let's do it so you can see. Case 1, x is in age group 0 to 4. But since what we want to print out is the same, we have an operator, the pipe operator like this, that we can use to combine cases that have the same outcome, like the same output. We want the same output. So say case 1, 0, 1, 2, 3. So now when we use this match statement, we provide the value, which is x is equal to 23, and we check if that value is 0, 1, 2, 3 for this. So with this, we don't need the list that we created. We just use the match statement. We can see that using the match statement reduces all our if, elif, and we can provide a case that will always match if no condition is met. So we use an underscore, and we always have to provide this as the last case. So we always have to provide this as the last case. We write this with an underscore, case, underscore, like this. And when it is underscore, means that it's just like a default, like a catch-all. X is not in the reference age group. So let's try to print out to see what this gives us. And then, so x is in age group 20 to 24. It does what we want it to do. Let's change the value of x to be 27. It should give us the same outcome. Let's change the value of x to be 0. It will tell us it's in age group 0 to 4. So it works fine, our match statement using cases. But when we put case is equal to 40 or 30, for instance, 30 is not in any of the matches that we want. And so it will say x is not in the reference age group, which will use the default statement here. So this is where we end this lesson. Thank you and see you in the next lesson.